All right, so now we are going to graph quadratic inequalities. And graphing quadratic inequalities is the same thing that we were doing before with linear graphing linear inequalities, except for now our graph will just be a quadratic instead of a line. So it's going to be a parabola instead of a line. All right, but our step one is the same, as we need to graph our boundary line of y is equal to, in this case will be a parabola, y is equal to x squared minus 4x plus 3. All right, I'm going to do this one on a separate page so I don't run out of space. So we need to figure out y is equal to, or graph y is equal to x squared minus 4x plus 3. So when we graph this, we would want to first find our vertex, and to find our vertex we use negative b over 2a, and I know my a is equal to 1 and my b is equal to negative 4. So I know a is 1 and b is negative 4, so I plug it in. Negative times negative 4 divided by 2 times 1. That will give me 4 divided by 2, which is 2. So I know my vertex is 2 for x. And then to find my y value, I just need to plug that back into the original equation. So y is equal to 2 squared minus 4 times 2 plus 3. So y is equal to 4 minus 8 plus 3. Y is equal to negative 4 plus 3, 2 squared, and y is then equal to negative 1. All right, so that means my vertex is 2, negative 1. So I'll go back to our problem. I'm going to just plot these points here. So we have 2, negative 1 as my vertex. And then if we want to make a graph of this, we should make 2 points that are greater than 3 and 4, and 2 points that are less than 1 and 0. So we'll go back to here. We have our table, 2, negative 1, and then we have 3, 4, 1, and 0. All right, and then we want to plot or figure out our points, so we plug them in. All right, so I'm going to plug in 3 first. So y is then equal to 3 squared minus 4 times 3 plus 3. So y is then equal to 9 minus 12 plus 3. So y is equal to 0. So when 3 is 0, y 3 and 1 will have the same value since they are the same distance away from our vertex. So 1 will also be 0. And then I'll plug in for y is equal to 4 squared minus 4 times 4 plus 3. So y is equal to 16 minus 16 plus 3. So y is equal to 3. So when x is 4, y is equal to 3. And that means that 0 will also have to be equal to 3 since that's the same distance away from our vertex. So we have the points 0, 3, 1, 0, 2, negative 1, 3, 0, and 4, 3. So we have 3, 0, 0, 3. All right, so now we need to plot these points. So our vertex was 2, negative 1. We had the points 3, 0, and 1, 0. And then we had the points 4, 1, 2, 3, 4, 3, and 0, 3. All right, now the next thing that we need to do is exactly what we did before when it was a linear inequality. Is it a solid line or is it a dotted line? All right, so nothing changes with that. So then we look at our inequality, and since it's equal to, it is a solid line. So now I can draw my graph, and using a solid line, I could then draw my graph looking like this. All right, and now same thing before. This cuts this into multiple regions or 2 different regions. We have the region inside of our parabola. So if I were to extend this graph out, we would have the region inside of this parabola. So it would be this region in here. And then we have the region on the outside of the parabola. All right, so same thing. We want to then shade our region. So we then need to plug in our point. Since 0, 0 does not fall on our line, we can use that point. So we want to shade our region, and we'll use the point 0, 0. And we plug it in. And we ask ourselves, is 0 greater than or equal to 0 squared minus 4 times 0 plus 3. So is 0 greater than or equal to 3? And that is, of course, false. So that means this point 0, 0 is not part of our solution set. So that means I need to graph on the other region that was created. So it will be the region that's created inside that U. So it would be this region here. So any point in this region will satisfy our inequality. And like I said before, there is a shortcut of graphing these by using the signs and just the signs. But for now, I want you guys to plug in the numbers and test it to see which region you want to shade. All right, we have one more question that we'll do for this, and then one more video and we're done.